From ancient Oriental mythologies to modern works of fiction, time travel as a concept has been around since time immemorial. However, is it more than just a curious concept? Can we reasonably expect ourselves to travel through time one day in the future? Physics already provides us with an understanding of how time travel can be possible, but actually possessing such technology in the future or understanding whether or not us soft and squishy humans could survive the journey is another matter. Ways to time travel. The easier ways. Black holes. In fiction, we often see spaceships going inside black holes and ending up at another point in time. In reality, however, such an attempt would likely pulverize and compress a spaceship to infinity. No, to travel through time using black holes requires us to orbit it at near light speeds just far enough to not get tangled into its event horizon, the area around it where not even light can escape its gravity. The theory of relativity states that gravity can stretch the fabric of time and space. The more the gravity, the greater the stretch. Around the black hole, time stretches to such an extent that by orbiting around it, you are effectively experiencing time at half the speed of everyone outside the black hole's influence. So, say you were to orbit around it for 10 years and then go back home to Earth, you would have traveled 10 years into the future. Cosmic strings. While a hypothetical concept, if they do exist, cosmic strings can provide us with the means of time travel. According to theory, cosmic strings are abnormalities left over since the early days of the cosmos, stretching across the entire length of the expanding universe. The creation of cosmic strings can be analogically explained as imperfections that form what a liquid solidifies. They are predicted to be impossibly thin, with a diameter of less than that of a proton, but contain an impossibly huge amount of energy and mass, bending space and time around it. According to scientists, the approach of two such strings close and parallel to each other could create such a large distortion that by carefully moving a ship around them, one could travel through time. Other methods. The infinite cylinder. Proposed by the astrophysicist, Frank Tipler, the idea behind this mode of time travel is very simple. Take matter roughly 10 times the mass of the Sun and roll it into an incomprehensibly long and dense cosmic cylinder, essentially a black hole spaghetti. Afterward, somehow get this object to start spinning at around 1 billion revolutions per minute. By following a very precise path around the cylinder, a spaceship can travel through time. However, there are some limitations to this. According to Stephen Hawking, this also requires the presence of negative energy to work, basically a thing that works opposite of gravity in that it pushes objects away. Scientists are still unsure of whether negative energy exists or not. Regardless, even it doesn't, there is another way to make the cylinder work, making its length reach infinity. Wormholes. Think of spacetime as a single sheet of paper. When you bend it, eventually there would be an instance where 2 points of it on the opposite come in contact with each other. This is what wormholes basically are, a connection between any two instances of spacetime. Thus, by taking a ship through a wormhole, you can possibly land in any instance of time. Although when and where would be outside your control. Controlled time travel with artificial wormholes is still possible. This would require you to create 2 wormhole entry points, one where time is normal and one where it is slower. Anyone coming from the region of space with a slower time would effectively travel back in time when they enter the normal time region. However, how old the instance they can travel back in time can only go as far back as the initial creation of the wormhole. However, while the existence of wormholes is theoretically plausible, actual evidence of their presence still remains to be discovered. Creating artificial wormholes is an even greater impossibility, as there are current theoretical models that allow us to create wormholes without violating some fundamental aspects of physics. Traveling through a time machine? All the instances we have discussed have involved some use of cosmic objects to travel through time. What about the more popularly imagined means? A time machine that physically travels through time. Is this possible? Again, such an approach would require you to somehow distort the fabric of spacetime in the region around it. You can technically achieve it through a heavy concentration of negative energy, but such an attempt would result in the destruction of the time machine and you as well. An alternative would be to create a donut-shaped hole composed of a vacuum inside a spherical object. By concentrating gravitational fields inside of this hole, spacetime could be bent. A person can time travel in time by racing inside the donut, going further and further backward in time with each lap. The problem is, of course, creating a strong enough field to start with. How to accurately manipulate it to safely achieve the intended purpose would also be difficult. Imagine standing on a black hole. Whatever happens to you in the next nanosecond is what would happen to you in an unmanipulated concentration of gravitational fields within our hypothetical time machine. Conclusion. There is a reason why you or I haven't met a time traveler. Based on the current understanding of how things work, time travel is practically impossible, either because it is too impossibly dangerous or too impossibly difficult, even with some form of futuristic technology. Some may argue that, provided their actual existence holds true, natural wormholes could have propelled people or objects through time. However, the significance of such an event occurring would not be too different from a scenario where no such event occurred at all, because the capacity of any time-traveling agent to successfully influence events would be nil. It is impossible to truly appreciate the vastness of space. The probability of someone going through a natural wormhole and going back in time to be even remotely near the same point in space is practically zero.